Episode 207 of CppCast with guests Botond Ballo and Tom Honermann, recorded July 25th, 2019. This episode of CppCast is sponsored by Backtrace, the only cross-platform crash reporting solution that automates the manual effort out of debugging. Get the context you need to resolve crashes in one interface for Linux, Windows, mobile, and gaming platforms. Check out their new Visual Studio extension for C++ and claim your free trial at backtrace.io/CppCast. CppCast is also sponsored by CppCon, the annual week-long face-to-face gathering for the entire C++ community. Come join us in Aurora, Colorado, September 15th to 20th. In this episode, we discuss news from the Cologne ISO meeting. We're joined by committee members Botond Ballo and Tom Honermann. Botond and Tom tell us about what got added and removed from the C++ 20 draft paper. Welcome to episode 207 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how's it going today?
I'm doing all right, Rob. How are you doing?
I'm doing just fine. I'm excited to dig into this interview.
Yeah, lots to talk about today.
Lots to talk about, yeah.
Although I guess before we go on to the interview, we should mention, we are in the heyday of C++ conferences right now.
Yes, we are.
And the flagship conference, if you will, CppCon, is coming up here in September.
And we should mention quickly, the schedule for that is now available. So I just got the email today, I think, that I can schedule all my classes or all my conference talks. Yeah.
Yes. And I just saw as well, I think I'm evenly spread out throughout the week. I'm like Monday, Tuesday, and Friday, or Monday, Wednesday, and Friday, something like that.
Nice.
So if you haven't signed up for CppCon yet and you're planning to, go do it.
Obviously, yeah.
To our listeners.
Yeah.
Book your hotel room. Make sure that you're ready to go. There are still plenty of openings in the classes and a huge selection of classes. I know I've already done the shameless self-promotion of my classes.
Nothing wrong with that.
The list of instructors on here is like a who's who of who's been on CppCast, really. We've got Arthur O'Dwyer and Charlie Bay and Klaus Eagleberger and Patrice Waugh and Diego's teaching a class and Phil Nash. So, yeah, quite the collection here. Matthew Butler, we've had him on, right?
Mm-hmm. Yeah, lots of classes to choose from, and they're both pre- and post-conference classes, so definitely take a look at those if you are signing up to go to CppCon.
Yeah, there's a lot going on here.
Yeah. Okay, so at the top of the episode, I'd like to read a piece of feedback. This week, we got a tweet from Tyler Young saying there should be enough material here to keep CppCast and CPP Chat busy for, another year? And he's linking to the Reddit C++ Cologne trip report, which I think we're going to be talking a lot about this episode.
Indeed, the agenda for today, right?
Yeah.
Although it won't keep us busy for another year because we're going to have to cover this. And then in the next standards meeting, we're going to be talking about C++ 23, basically.
I was looking at the schedule, and they don't go straight into 23. I think it's going to be like this time next year when the first official 23 meetings start, because they still have all the ballots to respond to and whatnot, right?
But theoretically, we're not talking about new features after this.
Yeah.
But we'll talk to our guests about that.
Go ahead.
Yes, the evolution groups will start be working on C++ 23 features, but we won't actually be pulling them into the paper for a few.
Okay.
Yeah, there's kind of a pipeline of different subgroups that look at standards proposals, and so groups that are earlier in the pipeline are ahead of the curve. They move on to newer standards, to material for new standards, a meeting or two in advance of groups later in the pipeline, so that we're always busy all the time with new material.
Yep. In fact, even in Cologne, there were some things that were forwarded out of the evolution groups targeting C++ 23.
Makes sense. Okay, well, let's...
It might be time to introduce our guests.
Yeah, let's go ahead and introduce our guests. So first we have Botond Ballo, who is a software engineer at Mozilla, where he has been working on the Firefox web browser's rendering engine for 6 years. He's been attending C++ standards meetings, meeting for about the same time, and blogging about them to keep the C++ user community informed about the standardization progress. In the committee, his interests include general language evolution, reflection, and tooling. Botond likes to hack on IDEs and other developer tools in his spare time. Offline, you might spot him climbing rocks or reading fantasy novels. Botond, welcome to the show.
Hello, thank you.
And Tom Honermann is a software engineer at Synopsys, where he's been working on the covariety static analyzer for the past 8 years. His first C++ standard committee meeting was Lenexa in 2015. He currently chairs the SG16 Text and Unicode study group and participates in the SG2 modules, SG13, HMI.io, and SG15 tooling study groups. His contributions to C++20 include the new char8t built-in type, a C++ minion with 20 years professional experience, husband and father of 2 awesome boys. Tom, welcome to the show.
Thank you very much. Very happy to be here.
So we've already hinted that the agenda for today is to discuss the last standards meetings, but just in your 2 bios, I'm pretty sure we could have complete separate interviews, full length. If you don't mind, I want to ask Botond, you said you work on the Mozilla rendering engine.
Yep.
And at the moment, pieces of that are moving to Rust land, right?
That's right. Yeah, that's a process that started about 3 or so years ago. Although the roots of writing parts of a rendering engine in Rust go back further than that. There's been a research division at Mozilla that actually has a complete functional rendering engine called Servo written in Rust. Now, it is a research engine. It's functional, but not really production use ready. But that's been an effort ongoing for a while. And in the past 3 or so years, we've been taking bits and pieces of it and lifting it into our production rendering engine. And so, again, there are just a few components at the moment. An entire replacement or rewrite of our production rendering engine in Rust is probably going to take something on the timescale of a decade or 2. It will very much continue to be a lot of C++ code. But yes, Rust is the long-term future as we see it.
And what does that interoperability story look like right now? We don't have a ton of time to really dig into it, but just kind of at a high level, parts of it are in Rust, parts of it in C++, they talk well together?
Yeah, fairly well. As in the case of most pairs of languages, the common denominator is a C FFI in interop layer. But we've been making some pretty interesting advancements in areas like cross-language link time optimization. That's actually a project that just landed in recent months. And it means that we can be more liberal about where we cross the language boundary without introducing performance bottlenecks.
It sounds like that assumes you're also compiling your C++ with Llvm, basically, with Clang.
Yes. So this is for the case where we compile our C++ code with Llvm, which we're starting to do increasingly even now on Windows. We compile with Clang and Llvm, thanks to the work that they've been doing to support the Microsoft ABI. That's not possible.
Very cool. And Tom, if you're working on Covariety, you must have a unique perspective on the language, I think.
Perhaps. I work on the front-end side of it, focused on our translation from the abstract syntax trees or AST from either EDG or Clang into our own internal representation.
Okay.
And then we have other people that work on the analysis side, so I don't know a whole lot about what happens on the analysis side. If you ever wanted to explore that, I would recommend my colleague Charles Henry Gross would be a very interesting candidate to have on here to talk about that. But for me, we need to really understand the language so that we can represent it properly within our database so that the analysis can run on it and find all the bugs that you don't want to have to find yourself.
So you use the Clang front end to build you an AST, then do some manipulation on that and pass it along? Is that what you said?
Yeah, basically. We have our own internal AST or representation. And then we use Clang and we use EDG, the 2 different front ends for depending on which compilers we're trying to work with. And so we take what they give us and we turn it into what our common needs are for our analysis.
That sounds like it makes a lot more sense than trying to write your own parser.
Yes, trying to write your own parser for C++ these days Yeah, that's a large effort, to say the least.
I can attest to that being a very uphill piece of effort, because I've actually worked on an IDE, Eclipse, which to this day, in fact, uses a homegrown C++ parser. And it is quite buggy and of lower quality than Clang-based tools as a result, because parsing C++ is a big job, and especially keeping up with new language features and so on, and doing all of it accurately. I think for newer tools and newer tooling projects, there's an understanding that you really do need to be based on an actual compiler front end.
Right.
Yeah, and it is really fun seeing the various bug reports that we get and the various edge cases that we hit. You're looking at the front ends, and as much resources go into EDG and Clang, there's still bugs there, and even understanding what's happening in a lot of those cases, it's really hard for the experts.
Right.
Great way to learn the language.
Okay, so I think we're going to skip the normal news section that we would do with most episodes, because we're going to be focusing on all the news from Cologne, where you were both attending. But before we get into that, maybe you could tell us a little bit about how you got involved with the ISO committee. Maybe Botond, start with you.
Sure, yeah. So I got involved just by, I've been programming C++ since the C++ 98 days. And at the time, the language was in a period of kind of stagnation. But there was this talk of all this cool new stuff happening in a new revision of the language, which at the time was called C++ OX, because it was projected to be publicized early in the first decade of this millennium. And as we know, that schedule ended up slipping a bit and it ended up becoming C++ 11. But it was an exciting thing to follow and keep an eye on. And then once C++ 11 was out and we got all this new goodness, that wasn't the end of the road. There was even more stuff. And particularly at the time, there was a major feature called concepts, which people had been hoping would make C++ 11, but it didn't. And so I was particularly excited about that. And so I was looking at, if it didn't make C++ 11, what will happen to it? Maybe they'll make the next revision. And so I was just following the online, various online communities about what happens there. And that's where I learned about the standards meetings and the fact that they're open to the public. And then I thought to myself, hey, if they're open to the public, wouldn't it be awesome to check one out sometime? And so I started looking at whereabouts they are. And as it happened in, I believe, September of 2013, there was one in Chicago, which is just a few hours away from Toronto, where I'm based. And I figured, hey, why not check it out? And so I did, and it was a really exciting experience, especially because you get to meet a lot of people who previously to that you had only known through books. Right? Like you meet people there who have written books about C++ and who teach courses and all that stuff. And so really awesome to meet these people in person. So I was hooked from the first meeting. And fortunately, I joined Mozilla around the same time, and I was able to get their generous support to continue attending the meetings, which I've been doing.
Very cool. How about you, Tom?
Kind of similar hook with the concepts stuff. What had happened with me was I was working on a project that included Java and C++ and doing some JNI work there and trying to rework how this code worked because it needed some help, and discovered that character encodings, right? Java uses modified UTF-8 in its interaction with C++ APIs. And I was impressed by how challenging it was working with encodings and crossing these borders. And I started getting interested in what would be a better API for dealing with encodings in general. And I came up with this idea of a text view, which is iterators for doing decoding and encoding. And I played around with it for a while, and I remember struggling with it, and eventually decided either I'm going to stop doing this or I'm going to try using concepts to help me out. And so I tried applying concepts to the design that I was working on. And it just unlocked my brain, and I was able to make good progress on it. And eventually decided, maybe this is something worth bringing to the standard committee. And I started doing some research, and like Botond said, discovered anyone could kind of show up at these meetings. And In 2015, I discovered Synopsys had a professional development program where we could spend a week at a conference and such. And I thought, you know what, I'm just going to go crash Lenexa and see what happens. So showed up there and got to meet lots of people. And like you said, I was hooked as well. So worked with Synopsys to keep going and try to get more of us going to these meetings because it's important for what we do, right? Following the language and in particular, static analysis, undefined behavior, is very much in the realm of things that we want to be able to analyze.
Now, I'm curious, since you now both mentioned concepts as your hooks, but I feel like we're talking about two different concepts because, Tom, when were you first introduced to concepts?
I actually was a little bit... I started playing with C++ 0x concepts.
Oh, okay.
Back around the C++ 11 timeframe, but that was before the things I was just talking about. So I've been following it through then.
Now, I have to ask the most loaded question I've perhaps asked ever on CppCast. Since you both were hooked into the standard because you thought concepts look awesome, and now the concepts that we're getting in C++20 are effectively completely different from the things that hooked you, how do you feel about that?
You're right. That is a bit of a loaded question. The design of concepts has evolved a bit since the C++ OX days. And I guess, it evolved in various ways. But I guess for me, the most important difference is that and again, I apologize if this description sounds a little bit biased, but I think it's legitimate for explanatory purposes. It feels to me that the concepts we got are sort of half the feature that we were going to get in OX.
Well, they are called concepts light, so...
Well, yes, and that's why. Because what we were going to get in concepts light involved checking call sites as well as checking definitions, right? So a concept is basically like an agreement between the users of a function and its definition. The users say, I'm only going to give you things that meet the requirements, the declared requirements. Okay. And the definition side of the agreement is, I'm only going to use the things that I have required.
Okay.
And both of these can, in theory, be checked independently. So the use sites can be checked that they are, in fact, passing in things that meet the requirements. And the definition can also be checked in isolation, that it only uses things the requirements provide for.
Okay.
And in OX, both of these sides of checking were going to be done by the compiler. Whereas in the feature we have today, it's only the use side checking and not the definition checking that is done.
Okay.
And so, I understand why it sort of had to be that way. The definition checking side was a very hard problem. It had performance problems. It had soundness problems. But I do, in a high-level sense, miss that ultimately.
Okay.
Yeah, I tend to agree with the characterization that we got about half of what was in C++ 0x in terms of the feature set. But I think in terms of value, I think we got about 90%.
Oh.
Because the user checking side is really where the most impactful part. People have been writing templates for quite some time. They've figured out tricks and such to and good ways to test their own templates to make sure that they are what they intend to be. So that part is not as concerning to me. The authors of the current concepts, have been pretty bullish about this, that they don't miss the definition checking, which I think is good. I also think the definition checking that was present in C++ 0x, well, it's often stated that it was complete, right? That if it definition checked, you were good to go. But that wasn't completely true. There were edge cases where you could still have a definition that would not instantiate correctly at compile time. And using it was challenging because it became really restrictive as to what you could actually put in your template. If you wanted to do any kind of logging or anything like that, you couldn't, because if that wasn't part of the interface, then it couldn't be part of the implementation.
Right.
So what we have now really gives us, plenty of flexibility for library authors while getting us, the usage checking that was really the most important part of it, I think.
All right, good.
Yeah, I think that's a fair point. I think what we ended up with is ultimately a pretty solid language feature, and it has a lot of utility for C++ users.
Well, I'm glad you both feel optimistic about it.
Yeah.
I didn't know where that was going to go.
Okay, so I want to start digging into some of the work that went on at the Cologne meeting where you both were. And I think it's worth starting with a feature that was actually taken out of C++20, which is contracts. It was first voted in, I think, a year ago at Rapperswil, but it was taken out this meeting. So can we start with just kind of what happened? What was wrong with contracts that it was taken out?
Oh, man, how much time do you guys have?
I would say that it had some controversial aspects for a while, and bringing those to light has been challenging. One of the conversations I had during the week was with people about axioms and assumptions, right? That we want the ability to use a contract to feed into the optimizer and let it optimize the code better. But that has some interesting implications to it. And it's in the case of axioms, many people have been striving to understand what's different between just assuming a contract and having this idea of an axiom. And so trying to get people to see this the same way is I think ongoing work that the study group that's been formed now may have to continue exploring. We could dive into that more, but it's a big conversation, a big discussion all by itself.
Yeah, I think one of the things that makes contracts a challenging feature to standardize is that even though they're, one thing in the code, there is a very wide variety of potential use cases for them, and sort of ways you can apply them to various purposes, ranging from optimization to static analysis to runtime checking. And obviously the committee is a very diverse group of people from different domains and different areas, different sort of styles of programming and models for software life cycles and all that. And so it's really hard for people to agree on a single set of rules that can apply to all of these various use cases. And so I think that's what a lot of the wrangling is about. I feel like the feature has been under debate for years, and it often engenders mailing list threads with hundreds of posts on them. That can be challenging to follow at times. And sometimes you feel like you get an agreement on something, and a little bit down the line, that agreement disappears, and that's what I think happened. We thought we agreed on it a year ago, and people weren't so sure now, and there just wasn't enough time to figure it out. And the schedule is pretty firm. The train moves on, and the C++20 train, it was time for it to go. And a feature that was in this current state of uncertainty was not ready to be on board. So we will revisit it, and I'm hopeful that we will get a better fleshed out feature in the C++20 timeframe.
Right. Ultimately, I think the biggest questions during the week were the idea of build modes and whether they belong in the standard, whether they should be prescribed, how much implementation freedom there should be for using them. The adoption of P1607 on Monday there was some would describe it as a very radical design change from what we had previously been working on. Some would say it's more of a tweak, which is why it got discussed and talked about. But ultimately, its goal was to improve the flexibility in using the concepts or using the contracts in order to better facilitate composition between different components of a large-scale product. So what we had in the working paper going in really didn't have much of a way for saying, for this particular module, or component, we want to build a certain way, and over here we want to build another way and mix and match. And that was definitely a challenge.
So we had contracts going into Cologne, And then you're saying on Monday, a big set of changes for contracts were voted in. And then by the time you got to Friday, all of contracts were removed.
Yeah. So basically, the reason we were even considering changes on Monday is because over the past few months, during mailing list discussions, it became apparent that people were not happy with what we voted in a year ago. Yeah. So I think what was clear going into the meeting is that something had to change. And so different people had different proposals for what directions we could change in. And something had consensus on Monday, but it turned out to be too big of a change for us to be comfortable making it at this late stage. And that's why the ultimate decision ended up being to pull it. So we weren't happy with what was already there. It was too late to make a change to something else, so that left not having it at all.
Okay.
Yeah, it was interesting though, because the vote on 1607 was basically 28 in favor and 9 against, which is pretty good consensus. But then the vote to remove contracts on Wednesday was 49 for and 11 against, which is definitely strong consensus.
Wow.
So it was interesting watching how things changed during the week.
And people also as new information comes in. So like I will confess, I was on the in favor side both of those times, right? So on Monday, I thought this change is great. And by the time we had that second vote about removing it, I still thought the change was a good direction, but I agreed with other people's arguments that it's a late change to be making in this version of the standard.
Right.
Yeah.
Right. And so, Tom, you mentioned that there's a new study group devoted to contracts, and hopefully we'll figure it out and fix the feature in time for 23. Is that the plan?
That's the plan. Yeah, John Spicer is chairing that group. There's a new mailing list that has been created, and I don't think there's schedule yet for new telecoms and meetings, but that'll be coming. And so we'll get some more activity going on, more people involved, and I have no doubt that we'll get something better. Just like we did iterating on concepts, we'll iterate on contracts, and we'll get something that will be better in the end.
I think aside from Constexpert, contracts are the thing that I was most looking forward to, because as a teacher particularly, anything that I can give my students that say this is a tool that helps you write more correct code and APIs that are harder to use wrong, that sounds great. So hopefully, I'm looking forward to seeing what comes out of it.
Yeah, me too. Yeah, especially, for working for Coverity, contracts are definitely relevant to what we do.
Oh,
so
right.
Being able to take advantage of those and, find more defects.
Right. See where you're violating contracts and...
Yeah.
Interesting.
I want to interrupt the discussion for just a moment to bring you a word from our sponsors. Backtrace is the only cross-platform crash and exception reporting solution that automates all the manual work needed to capture, symbolicate, dedupe, classify, prioritize, and investigate crashes in one interface. Backtrace customers reduce engineering team time spent on figuring out what crashed, why, and whether it even matters by half or more. At the time of error, Backtrace jumps into action, capturing detailed dumps of app environmental state. It then analyzes process memory and executable code to classify errors and highlight important signals such as heap corruption, malware, and much more. Whether you work on Linux, Windows, mobile, or gaming platforms, Backtrace can take pain out of crash handling. Check out their new Visual Studio extension for C++ developers. Companies like Fastly, Amazon, and Comcast use Backtrace to improve software stability. It's free to try, minutes to set up, with no commitment necessary. Check them out at backtrace.io/CppCast. Okay. Going on to some of the features that were added to C++20.
We're moving pretty slowly just for the record here.
There's a C++20 synchronization library. Do you want to tell us a little bit about that?
You skipped standard format.
I'm sorry. Go ahead.
I just want to say standard format was voted in. Maybe we don't have to dig into it, but I like that.
Yes, it was, and I think it's overdue to have a formatting library that's better than C-style printf or standard IO streams.
Yeah.
And this is the one based on FMT, right?
Yes. Yeah. It doesn't have its own printing utility, but it has its own formatting utility, and I think it's long overdue.
Yeah, it's a great piece of work. And the author has already, for C++23, been working on the scanning side of it now.
I asked him about the scanning side of it a couple months ago on Twitter, and at the time he was, I don't know, would there actually be use for this? And now all of a sudden it's, becoming quite serious. So
yeah, we reviewed it. We reviewed what he's working on in SD16.
Yeah,
this last week. So yeah,
a type-safe scanning library I think would be awesome. Really, I really do. All right,
for sure.
Now we can move on.
I didn't mean to skip it. My eye just glanced over for some reason. So yeah, C++ 20 synchronization library. Can either of you talk a little bit about that?
So one of the things about the committee is that there are a lot of subgroups, a lot of things going on in parallel. In fact, if I'm not mistaken, at this meeting for the first time, there were up to 9 parallel tracks. So there were days or parts of days where 9 groups were meeting in parallel.
And I believe our previous record was 6 or 7?
Yeah, something like that.
Was
something like that.
Wow.
And so obviously, one of the implications of this is that you can't follow in detail every subgroup's work. Even though it might be super interesting. And so, yes, I have heard about the C++ 20 synchronization library, talked about in plenary sessions and informal conversations and so on. I have not actually been in the group that was discussing the details of it, because it was just one of the 9 that I did not get to pop into, unfortunately.
Yeah. And I'm in the same boat. I've never attended an SG1 meeting, so I don't know the details there either. And with regard to Botond saying, that we can't be, with all the ways that we're spreading out in these different subgroups, you can't be everywhere at once. That's certainly true, but somehow or another, Botond does happen to make it look like he was in every one of those rooms when you read his trip report.
Also, to be fair, my trip report does have a focus on the evolution group, which is where I sit for most of the time. But yes, I try to gather bits and pieces of information about what else goes on and try to mention it.
How about context per allocation? Can you talk about that?
Goodness.
I think that one is I know a little bit more about. It's a very exciting proposal because it greatly expands the set of sorts of things we can do in context per functions. Namely, we can now use things like vector and string that perform dynamic allocations. And so I think this is a really important step towards the committee's goal of making compile time programming be more like regular programming. So certainly vector and string are very regular programming types of things. They're sort of everyday things that you want to be able to use to express basic things. And so being able to use them, I think, is an important milestone there. It was a challenge, as I understand. So I'm not a compiler implementer, but from the conversations I've had with compiler implementers and from what I've heard them say in session, it definitely was a challenge to implement and to even come to an understanding that it's implementable. Right. So the early stages of the discussion were, we'd really like to have this. Can we though? And basically, some implementers ended up going off and doing some work, some research work in their implementations to try to prototype and just answer the question, is this implementable? And I believe the EDG folks were one of the pioneers in this area.
Right.
We just
had discussed that with David, a few weeks ago.
Yeah, David van der Voort, he does a lot of experimentation and sort of validation of new proposed features in C++. In fact, we have a little bit of a running joke where if the chair of the evolution group, which considers new language features, is uncertain about whether a particular feature, even just a detail of a feature, is implementable, he'll just ask David, and David will, come up with an answer on the spot for most things.
Which might look like, no, of course it's not implementable. Well, actually, maybe.
Sure. But this particular feature, context per allocations, was not an answer on the spot thing. It was a go off to the side and do some research. But the results of that research were promising, and so we ended up proceeding with it. And I believe there were a few road bumps here and there. In particular, we had to pull part of the feature where you could allow a dynamic allocation to survive to runtime.
Right.
And have it become just like a global, have the result of a concept for computation that involves dynamic allocation become just a global that survives to runtime. That's something we wanted to do, and we could not figure out how to specify it properly and in a way that all the implementers are happy with it and confident they can implement it. So that part was pulled. So you just get to use dynamic allocation during the compile time computation itself and then throw it away.
Then you have to shove it into a standard array or something like that at the end of the.
Yeah, that's
I would guess if you wanted you wanted that data to survive.
That's right. Yeah,
I'm okay with that, honestly. I've spent a lot of time in constexpr. I feel like that's probably the better idea. But part of reading this paper that I was just reading this stuff this morning, and my brain went zzz, because right now a literal type must be trivially destructible. With this paper, a literal type can have a virtual destructor. That is complete departure, like what literal types mean in my head. So it's going to take some rethinking on some things.
Yeah, so I don't know that the virtual destructor poses particularly more difficulty than virtual functions in general. I think there was
but the fact that you couldn't have a destructor at all before, and now you can, sure, it's a destructor, it could be virtual, whatever, inheritance, it's fine. It can all happen at compile time now. I'm going to have to go modify some of my, training material, basically.
Yeah, I think that was a conservative approach taken to avoid controversy and ensure implementability for, to begin with, and knowing that we could and probably would relax it eventually.
Right. Yeah, as constexpr has been every single release, more and more things relaxed. Yeah.
Yep. But yeah, to Botond's point about the implementability concerns, if I remember right, that was discussed at plenary even when we were voting the feature in, and there are still some concerns out there. So hopefully it won't encounter any more.
Oh yeah, good point. Good point. You're right. There was, I believe, an implementer. I don't know if I'm supposed to say which one, an implementer expressed some concerns still about the implementability.
I saw an implementer also tweeting after the plenary some concerns that they don't believe it will be implementable or are not sure if it'll be implementable.
Right. So, I mean, this is one of those things where we're at the stage in the process where if a fatal problem with a feature becomes apparent, there is still time to
pull it out.
To pull it out. Now, that said, I'm really hoping that this particular feature does not get pulled. And I'm optimistic that, if it's implementable in 2 or 3 implementations, it can be implementable in a 4th one with sufficient effort. But I guess that remains to be seen.
And this is why we have the feature deadline for producing the standard. There was another proposal that made it through EWG and through core this week, and that was to allow floating point types as non-type template parameters. And we actually put that up on the straw poll for plenary on Saturday. But then during the week, somebody objected that, this is a feature. This should have come in Kona at the latest. And so we ended up taking a procedural poll to say, do we, as a committee, want to allow this late feature into this release? And that poll ended up failing, so that we did not poll actually adopting this new feature at all.
Wow.
So there were lots of discussions about implementability and making sure that things have been implemented before. So if you want to bring a proposal to the C++ standard, implementing it ahead of time is a great way to help get people behind you and supporting your proposal.
Okay, and I think this was already mentioned, but since we're getting constexpr allocation, we're also getting std vector and std string will become constexpr, right?
That's right, yeah. And so there was a little bit of library work involved in formulating those classes, right? So we had to expand the language rules to allow more things on the language side, but also tweak the implementations of those classes a bit to fall into, to conform to what is now possible. And there are actually some language features to help with that. So we have a language feature called std is constant evaluated that allows you to provide a different implementation for compile time versus runtime for the same function. And while I haven't followed this in detail. I think String may have had to make use of that, such that it doesn't do some of the fancier things it does, like the small string optimization at compile time, because that involves, reinterpret casts and so on that you still can't do at compile time.
Oh, yeah. Okay, that makes sense.
But you want to still be able to have the small string optimization at runtime, so
and
now you can have both.
To go with this constantly evaluated, we also, if I remember correctly, we made it through to allow inline assembly in constant expert functions.
Yep.
Right. Unevaluated inline assembly.
Yes,
yep.
Which is a very important point. We're not expecting the compiler to actually evaluate the assembly, because that would be interesting. But that allows intrinsics essentially to be emulated at compile time or executed at runtime, as you would like for constant expert. So a very useful feature.
Yeah.
Okay. So now we kind of skipped over the C++ 20 synchronization library. Is there much to be said about stop token and joining thread? I think that also came out of SG1, right?
Yeah, so I don't know much about stop token, but I've heard some of the discussions about joining thread. And so basically, the idea with joining thread is that if you spin up a standard thread, a std thread, and you, so Tom, maybe you can help me out here. If the main program exits and your thread is still alive, is that when there's a debate about what to do there?
Yeah, with that there, you basically end up in undefined behavior if you don't manually join your threads properly.
Yeah, you basically, on all implementations, get a crash with you didn't join this thread. Yeah.
Right. And so there was a desire for either the standard thread's behavior changing or having a new facility which automatically joins in the destructor. And, people had arguments for not changing the behavior of std thread itself, but so we have a new facility. JThread, I think, is the name, or is it joining thread now?
It's JThread.
It's JThread.
I think the recommendation is, now that we have this, don't use std thread, use std JThread. And
right.
That's just what it'll be.
Let's see. I mean, anytime I talk about threading with students, they're like, well, why doesn't it just join when it goes out of scope? And I'm like, I don't know. Like every other thread implementation, I wrote my own RAII threads as pthread wrappers way back in the day before we had standard thread, and mine automatically joined when it went out of scope because that's what destructors are for, right?
That's right.
I think it's a welcome change personally.
Yeah, I do too. I just wish we could have fixed the original one rather than creating another one.
Well, we'll deprecate it at the same time we deprecate std-bind.
Okay.
Since I'm on the standards committee, right? I can just decree these things.
Yep. Oh yeah, we love deprecating things.
Okay. I think we're mostly getting into smaller features now, but source location?
Yeah, that's one that I've been looking forward to, because nobody likes macros, right? We want to exterminate macros and use modern C++ alternatives where possible. And I think we're at the stage where, for the vast majority of macros, that is possible, right? So there's no more need to have pound-defined constants or little function-like macros. There's really no need to have those in C++. But there were these pesky under file and under line and under function macros that just did not have a replacement. If you wanted information, if you wanted the compiler to automatically put in information about your line number and the file name and all that, that was the only way you could do it. And now there is a non-macro way to do it with std source location. So I think that's a very, very welcome feature.
Yeah, and I looked at this as a nice a rescue. The source location had been languishing in the Library Fundamentals TS for a while, and this Quentin Jabot, and I forget who the other author was, that went and decided to push it and get it out of the TS and into the working paper. So kudos to them for taking on that effort and getting it through.
Cool.
Yeah. How about using Enum?
So that's kind of a minor thing, but it's sort of fixes a paper cut right? So we in C++ 11 we have scoped enums, and that's good for sort of name hygiene, for not mixing, not just having your enumerators pollute whatever enclosing namespace that you define your enumeration in. You put them in this nice scope, and so that's great and all. But sometimes you're writing a localized piece of code where you have to just repeat those enumerations over and over again, and having to prefix them with the enumeration name just gets verbose. And so using enum allows you to introduce the enumerator names into some local scope of your choice, and thenceforth refer to them without the enumeration's name as prefix. One of those nice things that you probably don't even think about once you have the feature. It's like, of course you can do that. But you notice it as a small paper cut when you don't.
And thank you for having the summary for that one, because as we noted before, having like 9 breakout sessions, you can't follow everything. And honestly, I don't think I was even aware of this one at all.
So I'm not sure if we should go over every single feature, but are there any ones you guys want to highlight that you were involved in?
Well, so I think we can't have a discussion about C++ 20 without featuring its flagship, what I view as its flagship feature, even though it was voted in at a previous meeting and not at this one. So I'm thinking of modules. Modules was voted in at the previous meeting, but I think that just not having it pulled out at this meeting is an accomplishment. Is an accomplishment that I'm proud of, because there was a non-trivial risk of that, right? We at the last meeting, the state modules were in was that the implementers had come to a consensus, but there were other segments of the community, and Tom can perhaps tell us more about this, in the tooling community in particular, that had concerns about modules adoption. And I think up until this meeting, there was a risk that modules might get pulled over some of those concerns. And so I think that not happening is an accomplishment in and of itself.
I suspect if we had more time to work the deployment problem, that there would be more chance of that happening. So if modules had been under wrapper swill, then we'd had more time. Maybe now we'd be looking at it. So while I hope we're able to figure out the issues, I do think deployment and the deployability of it is a pretty serious concern. Based on what implementations, the direction that implementers are taking on it, the problems that it imposes on traditional build systems are effectively equivalent to generated headers. And so for those of you who have dealt with build systems and generated headers and how difficult those can be, those problems are now going to arise for adoption modules. So we'll have to see. There are a lot of people experimenting with different things. People from CMake have been attending the meetings and making sure that CMake will be able to handle modules well. Likewise for some of the other more modern build systems. For those of us that are still stuck on old make-based build systems, we're going to have to do some work to be able to take advantage of this down the road. But SG15 is continuing to explore our options there. We may have, and we may be able to introduce an implicit module use workflow through the compilers, which is what Clang modules has traditionally done. So Clang modules were very easily adopted because build systems didn't need to be modified to work with them. However, that brought along problems of modules being rebuilt multiple times and some ODR issues and such. So the implicit modules are not a perfect solution either. But we'll have to see how things shake out here.
Okay. Were there any changes made to any of the main features for C++ 20? Modules, coroutines, concepts, ranges?
There was a change made for modules in that.
Okay.
Previously, the working paper specified that some subset of headers are importable as importable header units. And the mechanism by which this is specified is up to the implementation. So like on Clang, it could be module maps, and other implementations it could be command line options or some other way of marking a header as being importable. And if you had a pound include directive for an importable header, it was treated as a import declaration, as if you'd done an import instead of a pound include. That proved problematic for Microsoft's implementation, and so we discussed that in this meeting and decided to make that whether or not that pound include translation happens is now implementation defined.
I wanted to comment on the integrate the spaceship operator into the standard library. I'm impressed that got through to modify the standard library for a timely feature right there.
Yep, I think that's important to have to have that library support with us, and I think it's the result of the committee taking care to identify features that have library impact and sort of front load them. So we have a schedule, and we've been trying to, I think in part because of the user community's positive reception of the regularly scheduled release of new features every 3 years, we've been trying to be more disciplined about sticking to it, but also ironing out kinks in the process. And one of those kinks is making sure that when a language feature has library impact, it is refined early enough that there's time for the library groups to go through the library and propagate the consequences there. I think there are some cases like class template argument deduction in C++ 17 where we kind of ran out of time to do that really properly. I think we did a better job now in 20 with Spaceship. So I think that's a success story for being disciplined a bit about the schedule and stuff.
Yeah, I agree. I think Barry Revson should get a good amount of credit for having done all that work and pushed that through. There was a number of changes that were made to the core language for the spaceship operator based on the work that he did integrating it into the standard library. So there were some good fixes that came there.
Yeah, absolutely. There were, as is often the case, there are issues we discover at a late stage. And yeah, big shout out to Barry and also David Stone, who spent a lot of time writing high quality papers to fix spaceship defects.
Yeah, and one place where I'm a little bit concerned is on coroutines, right, where we now have the language facility, but we don't have the library side.
Right.
Support for coroutines. So we'll have to see how this plays out going into C++ 23. Fortunately, Gore and folks here, they've done a lot of work on this already. It's been implemented and deployed. I think Microsoft is using coroutines pretty widely internally at this point. So there's good implementation experience that we could rely on. But we still don't have those library parts in the standard library. It'd be interesting to see what happens when they land.
That's an interesting point. And I had seen some complaints a few months ago about how ranges that we were getting wouldn't have all of the utilities for ranges that we want, but it looks like some of those ranges utilities did in fact just get voted in, if I got that right.
Mm-hmm.
Yeah, in particular the popular ones, the range views, which are super, super useful for allowing you to program in a bit more of a functional style with ranges.
Cool.
That did make it in, and I think a lot of people are pretty happy about that.
And that's another great example of how ranges influenced the final evolution of concepts and how it appears in C++ 20.
Yep.
So, getting that library experience is really, really valuable.
Yeah, concepts and ranges are a nice pairing of a language feature and a library feature that are landing together and ready for users to use from the get-go.
Yeah.
So I guess final word then, deprecate volatile? Yes or no? Good idea.
I don't know what to say on that one so much. I think it's probably a positive. In most of the cases that are deprecated are things people shouldn't have been doing anyway, or used for purposes other than what it may have been intended for. So
yeah, I feel like the deprecation hits a lot of corner cases that probably weren't super interesting to begin with. But yeah, volatile has definitely been misused for synchronization-related purposes. And I think, to be clear, we did not deprecate all of it. We deprecated uses of it in certain contexts. So I think reducing the surface area there for people to misuse it is a positive.
Yeah, and
I've never seen.
Volatile is essential for its correct uses. There's no workaround for it. We have it. So we need it, but we need it where we need it, not where we don't.
And it looks like they'll be moving in a direction of volatile load and volatile store to make it very explicit that that's what you're doing. Something like that.
Oh.
I'm guessing that's a like a standard library atomics type proposal, or I'm not too familiar with the specifics of it, to be honest.
Something like
that.
But
yes, yeah, okay. I can see utilities like that flowing out of the concurrency study group.
Right.
Okay. So now that we are past Cologne and C++20 feature freeze, essentially, what are you two looking forward to with C++23?
So for me, I think one of the biggest items, and to be clear, we got a lot of big items in 20, so I got to cross a lot of things off my list. But one of the big remaining things I'm looking forward to is reflection. Reflection is something that's been in the works for a long time. There is a TS, a technical specification out for it, but it is A, to my knowledge, not fully implemented anywhere, and B, it's not the final form in which we expect to get reflection in the language. So it's very much a work in progress, but there's been a lot of bright minds at it, a lot of implementers experimenting with it, and I'm optimistic that we will get at least one batch of reflection features in 23. With possibly further, more next-generation stuff like meta-classes later on.
How about you, Tom?
For me, well, as chair of SG16, the Text and Unicode Study Group, I'm very focused and interested in making some improvements there. In C++20, we put in some foundational work. So for one thing, the standard no longer refers to, the C++ standard no longer refers to a version of the Unicode standard that is older than some committee members. So that's an improvement. We now have a floating sort of reference to it. We made a change that doesn't affect any implementations, but as previously specified, the char 16 and char 32 literals were the encoding of them was implementation defined, but on every implementation it was UTF-16 and UTF-32 respectively. So we just decided to make that. Yes, we can count on that. It will always be UTF-16 and 32.
Wow.
Yes.
Okay.
And then we got the char 8T type in, so that we can now have strong types for UTF data, and that was motivated for three different reasons. One, in that the char-based encoding is implementation defined and locale sensitive, so it's hard to know what data you have in any char-based storage. So char 8T now gives us a way to clearly separate UTF-8 data from other stuff. And put the guardrails that people need there to avoid mixing them together and introducing Mojave into their application. And then along with that, we get an unsigned type for managing UTF-8 data. This char is often signed, and if you try to use it to inspect a trailing code unit type, it doesn't always do what you want, not portably anyway. And finally, char 8T it does not alias like char does, so there's some performance improvements that can come from using that when working specifically with UTF-8 data.
That's interesting.
So for C++23, what we're looking forward to is building on top of that and providing encoding-aware text and text view containers and views that support decoding when you need to work at a code point level with text, and probably some graphene cluster iterators so that we can look at what a user perceives as a character as opposed to the individual components. Transcoding support. Right now, I like to say that with char 8T, writing hello world is an expert-only activity because getting the data, the UTF data, into a stream in a way that isn't going to produce the wrong result portably is really hard. We just don't have the facilities in the standard to provide that transcoding support. So that's something that we're working on. Jean-Yves Menid has a proposal for that and is making good progress on that. And then finally, support for Unicode algorithms in general, and hopefully a good regular expression library from Hanna Dusupova. She's been doing some great work, which everyone's familiar with, and adding Unicode support to that with some help from Corinne and Jabot. And looking forward to hopefully that can land in the 23 timeframe as well.
That makes me think of the code CVT utilities that were added in 11 and then, I don't know, deprecated in 14 or 17. And there's a couple of us that actually need something there. So hopefully we'll get something real in 23.
That's the idea. That the entirety of Code Convert has not been deprecated. what was deprecated was just the ones that converted between UTF-8 and 16 and UCS2 and such.
Okay.
We eventually, I think...
Which is what we need when we're working on Windows.
Yes. And I think eventually we need to just deprecate all of the code convert facets and come up with something new. So yeah, I'm not sure that the code convert facets were ever a good idea to begin with. What I think makes more sense is layering the encoding awareness on top of the streams rather than having them being, embedded into it.
Right.
So hopefully I think we'll probably pursue that direction.
Very cool.
Yeah.
Thank you.
Okay. Well, it was great having you both on the show today.
Thank you for having me.
Great to be here. Thank you, guys.
Yeah, much appreciated.
Thanks.
Thanks so much for listening in as we chat about C++. We'd love to hear what you think of the podcast. Please let us know if we're discussing the stuff you're interested in, or if you have a suggestion for a topic, we'd love to hear about that too. You can email all your thoughts to feedback@cppcast.com. We'd also appreciate if you can like CppCast on Facebook and follow CppCast on Twitter. You can also follow me at Rob W. Irving and Jason at Lefticus on Twitter. We'd also like to thank all our patrons who help support the show through Patreon. If you'd like to support us on Patreon, you can do so at patreon.com/cppcast. And of course, you can find all that info and the show notes on the podcast website at cppcast.com. Theme music for this episode was provided by podcastthemes.com. At cppcast.com. Theme music for this episode was provided by podcastthemes.com.